In this video, I'm going to go over solving rational equations. What makes this a rational equation is, first off, there are rational expressions inside. And remember, rational means fractions. So if you notice, there are fractions with variables in them. Equations mean that there has to be an equal sign, and that is the case here. There's an equal sign. So in order to solve for a rational equation, there are many ways, but the one way that I show you in class is to make everyone have a common denominator. And that is very similar to what we did with the rational expression lesson in lesson 42. So if you notice, this denominator can become 5x, and I can make them all 5x by multiplying the first fraction by 5 on the top and bottom, and the last fraction by 5x on the top and 5x on the bottom. The middle fraction already has 5x on the bottom, so I do not need to do that. So I have 5 over 5x for the first fraction. The second fraction stays the same. And my third fraction is 5x over 5x. Now what I'm going to do next can only work in an equation. So because this is an equation with an equal sign and all the denominators are the same, I can cross all the bottoms out. Now please do not get confused with this and the rational expressions lesson. You cannot cross out that bottom in lesson 42 because they were not equations. They had no equal signs. But because this has an equal sign, I can do this trick of crossing off the bottoms. So what I'm going to do now, because I cross off the bottoms, I'm going to solve for the top. Subtracting 6, I get negative 1 equals 5x. Divide by 5, I end up getting x is equal to negative 1/5. Now it is very good practice to check your answers, and you can either do that by hand or with your calculator by using y equals. Because this is a video, I am going to check it by hand. And I'm going to put in 1 over negative 1/5 equals 6 times 5 times negative 1/5 plus 1. This becomes negative 5 when you keep change flip, and this becomes 6 over negative 1 plus 1. That'll be negative 5 equals negative 6 plus 1, and negative 5 equals negative 5, so that works. Now the only type of answer that wouldn't work, most likely, that is extraneous, is an answer that makes the fraction undefined. And in this specific one, x cannot be 0. And actually, this is a good thing to state to start. The reason why x can't be 0 is because if you put 0 in these two, there would be 0 on the bottom, and that makes it undefined. So in the next example, what I'm going to do first is state my undefined values so that when I look at my answers, I know whether or not to reject them. Okay, so in this example, before I do anything, I'm going to first try to state my undefined values. And I need to do something before that to even get there. What I need to do is make sure all the bottoms are factored to see what's inside of them. And the second one's not factored, so I'm going to get n minus 6 and n plus 1 to factor that. Now, if I look at this, I want to find what values of n I can't be, meaning that I want to find what values of n make the bottoms equal to 0. And those values are n can't be 6 and n cannot be negative 1. And if you notice, if you put 6 in, you get 0 for the last and second fraction. And if you put negative 1 in, you will get 0 for this fraction and this one here. So that being said, I know the two values of n that cannot exist, so I can go ahead now and solve. So what I'm going to do is I'm going to rewrite this with the new denominator for the second one. And I'm going to give each fraction what they do not have. Now the second fraction has both pieces, but the first fraction is missing the n plus 6, so I'm going to give that, the n minus 6, I'm sorry. So I'm going to give that to the first fraction on the top and bottom, and the last fraction is missing the n plus 1. Now again, like in the beginning of this video, I said you can cross out the bottoms because it's an equation, and all the bottoms have the same denominator, same factors. So I'm going to have 4 times n minus 6 plus 1 equals 1 times n plus 1. Distributing this in, I get 4n minus 24 plus 1 equals n plus 1. So on the left side, I have 4n minus 23 equals n plus 1. I'm going to subtract the n to bring it to the 4 and get 3n and add the 23. I end up getting 3n equals 24. Dividing by 3, I get n equals 8. And again, like I did in the first part, you should check your answers. But the biggest deal is that 8 is not equal to any of the undefined values we've found in the beginning of the problem, so it is a solution. Okay, so in this example, I'm going to start off by stating my undefined values of m first before I find my solutions. But before I can do that, I need to factor one of the denominators, and that would be this one, into m plus 1 and m minus 1. Now, that being said, I can now state the values of m that make this whole entire equation undefined. And that would be m cannot be 1 and m cannot be negative 1. M can't be 1 because of this piece here. If you solved it for 0, you would get 1. And m can't be negative 1 because of this piece here. So now I'm going to rewrite this with 2m, m minus 1, and rewrite the second fraction with both denominators equals 1 over 1. In order to cancel the bottoms out, I need to give them the same denominator. So I'm going to give the first one m plus 1 on the top and the bottom. And I'm going to give the last one both pieces, m plus 1, m minus 1, m plus 1, m minus 1. Now because all the bottoms are the same, we can cross them all out and only solve for the numerators. Distributing this in, I get 2m squared plus 2m plus m minus 5 equals m plus 1 times m minus 1. Now that just becomes m squared minus 1. If you don't believe me, you can do box, but we just factored that, so it has to be m squared minus 1. On the left, I'm going to add together the 2m and the m, so it'll be 2m squared plus 3m minus 5. M squared likes to be positive and equal to 0, so I'm going to subtract m squared and add 1 to make it equal to 0. And I end up getting m squared plus 3m minus 4 equals 0. Now because this is a trinomial, I am going to do am, and I'm going to think about my factors of negative 4 that add to 3. So I'm going to factor m and m, different signs, and I'm getting 4 and 1. Now I did this wrong because now that I notice it, I want a positive 3, so I should have put the 4 here and the 1 there. Okay, so now I can solve for m, and I end up getting m equals negative 4 and m equals 1. But if you remember, we said that 1 cannot be an answer because it makes our denominators undefined. We stated that up here. So I'm only going to accept the answer m equals negative 4 because m equals 1 is an extraneous solution. You were able to solve for it, but it did not satisfy the original equation.